Thanks everyone for joining us. We will now officially begin today's webcast. My name is Andy, and before we begin, I have a few housekeeping items to take care of. Today's webinar, The Power of Ensembles and Automated Machine Learning, is scheduled for 30 minutes, including time for question and answer. After we complete the presentation, we'll go straight into Q&A, so please submit questions as they occur to you via the Q&A box on your Zoom webinar console. Due to the number of attendees, the phone lines will remain muted throughout the presentation. We will make a recording of the webinar and the slides available following the webinar. Our presenter today is Vlad Kazanov. Vlad is a machine learning engineer at Auger.ai, working there for more than a year. He has 4 years experience in general machine learning and 3 years in deep learning. Prior to starting at Auger, Vlad worked as a data scientist for a number of European and American companies. Vlad, go ahead and take it away and share your screen when you're ready.
Hello, everyone. So thanks, Andy. So today we will talk about model ensembles. Model ensembles is a powerful tool in machine learning, which helps us improve our predictions using several different machine learning models. I want to start with an example. So imagine we have a classification problem with 4 classes, which are represented by colors, red, pink, green, and blue. And we have 2 models. And on the left side, we have regions for classification regions for each model respectively. And as you can see, the first model classifies well green and blue points, while the second one classifies well red and pink points. And this way we can combine them together in order to improve our accuracy for all classes. And on the right hand side, we can see the classification region for combined for ensemble of these 2 models, and it has better accuracy. As you can see, the red and pink regions are remaining like circles as naturally as initial distribution of respective classes, while green and blue classes concentrated in the center and well separated by regions. So one other opportunity of model stacking is preventing overfitting. So imagine we have a binary classification problem with 2 classes, plus and minus, respectively, and we have 3 classifiers, which are depicted on the top with the red separation line. And as you can see, all of them works well, like 100% accuracy. However, all lines are different. And if you take an average over all of these lines, we obtain the blue line like one depicted below. And you can see that it has much better separation properties. It's very similar to SVM large margin approach, but we can do this for free without even knowledge about SVM. So the next important thing in stacking models is correlation between predictions. So consider the following example. Let we have a binary classification task again, and the true values are always equals to the first class, while 0th class is caused an error in our predictions. And we have 3 different models on the left and on the right. So for the first 3 models, the correlation between them is about 86%, which is quite high. However, the accuracy of each model is 80 or 70%, so which is quite high. So if we take the majority voting approach for stacking these three models, we won't get any improvement. So we had previously 80% accuracy, and we obtained 80% as well. That's because predictions are highly correlated. However, consider another three models on the right-hand side. There we have three models with like average prediction less than in the first part. However, the correlation is about only 70%, 17%. And this way we can obtain an improvement. And as you can see, for instance, for the last observation, we have two ones and only 1 0. And this will give us the first class by majority voting. And the resulted accuracy will be 90%, which is an improvement. However, neither of the previous model has such accuracy. So the improvement is about 10%. So in Auger, we usually use a bunch of models, and we have several optimizers which tries to find the best one. And since we have trained a bunch of models during the search space step, it's natural to include ensembles into an Auger. So Auger utilizes the results from several models and tries to combine them in order to improve the final accuracy. And also we apply several heuristics on the choosing the models in order to shrink the search space. So the first stacking algorithm is averaging or voting. This actually averaging is a particular case of voting with the equal weights. So first we have a bunch of models, say n models from the leaderboard, and we calculate the Pearson correlation between predictions of those models. After that, we choose only models which doesn't correlate much, because as we can see on previous slides, highly correlated models doesn't improve the final accuracy. And once we filter the model using the correlation between them, we calculate the weighted sum of this model, and the weights are determined by the model's accuracy. Like the higher accuracy for a particular model, the more weight is put on it. And an ensemble is actually a weighted average of that model. While it's for voting, and for averaging, we just put all weights are equal to 1 divided by the number of models. The next one is greedy selection. So greedy selection algorithm took several top models from the leaderboard and create an initial ensemble. And then it iterates over all the remaining models, and one by one try to add it to the existing ensemble and check if the recently added model improves the final score. And in case no, it throws it away and moves to another model. While if it improves the final score, it adds it to the current ensemble, and again move to another score until we loop over the all models. One other stacking algorithm is superlearner. So for superlearner, we use an optimizer such as LBFGS or SLSQP for calculating the optimal weights for our models which are going to be stacked. So one other important thing is that we use cross-validation during model selection, and we use the predictions only on holdout set in order to reduce overfitting. So the result is the matrix with the number of rows equals to the number of records, and number of columns equals to the number of models which we want to stack. And in case multi-class classification, this will be a cube, and we use mentioned optimizers in order to find the best linear combination in order to improve the final accuracy. So the improvement of the previous approach is deep superlearner. It is something similar to neural network, where we have a bunch of models, say gradient boosted models, some perceptrons, k-nearest neighbors, and so on. And we blend them together in order to obtain some predictions. However, in deep superlearner, we use such predictions together with initial predictions and combine them in order to create one more layer of predictions. And then we continue these iterative steps until our final accuracy improvement will be below some threshold. Then we stop this process and freeze this computation graph, and this will be our final model. One disadvantage of this approach is that it's quite slow. However, it's one of the most powerful stacking techniques for today. And some use cases. So here are 3 competitions from Kaggle: head pose estimation challenge, acquire value choppers challenge, and forest cover type predictions, where the winners of the respective competitions shared their results, and they use different stacking techniques which we have just described, and they got an improvement, in some cases a decent improvement for the final model. So for head pose estimation, they have 0.2 improvement in mean absolute error metric. For acquire value choppers and forest cover type prediction, the improvement is much less. However, on competitions, this is also valuable. So thanks everyone for listening. I'm looking for questions from you.
It helps if I unmute myself before I start to talk. So thanks for that. That was a great overview on looking at ensembles in AutoML, Vlad. Really appreciate that. I do have a question here. How is your product philosophy different from that of other AutoML products, such as Data Robot or H2O's driverless AI?
Okay, thanks for the question. So actually, in this perspective, these products are quite similar. I'm not sure that, for instance, H2O driverless AI has as much ensembling options as we have. However, they're really quite similar. Although our product is not limited by only ensembles, we have a bunch of optimization techniques, some data pre-processing, and so on, from which our product benefits.
Great, thank you very much, Vlad. Right now, those are all the questions we have. That one is the only question that I have from folks. So it appears as though you did hold on a minute here. Sorry about that. I've just had a couple come on. So let's see, what ensembles have you seen win Kaggle, and do you support them?
Yes. Actually, most of time, Kaggle competitors use just simple voting. However, they use them in order to stack different models from different competitors, while each competitor individually uses ensembles as well in order to obtain his own model. And usually it depends on the dataset size. And if the dataset size is not, say, too much, then deep superlearner usually used. However, for large datasets, it's very computationally expensive and uh, more simple stacking algorithms are used, such as voting or like logistic regression stacking.
Great. Another follow-up question here. Are the target users for this non-technical, meaning people like analysts, or technical, more like data scientists? Great question.
I guess both can benefit from it.
I would agree as well. I think the technical data scientist type folks will be able to jump into this and really be able to probably maximize various aspects of what Auger can do, what AutoML can do. But it's certainly for Auger at least, it's accessible to the non-technical people. Somebody like me that doesn't have the necessarily the data science background found it pretty easy once I was given a quick run through to take a data set and launch that in Auger and start to process that. So yeah, I think it's probably something that both subsets of folks could find valuable. So that is that's the end. I don't have any other questions that have come up. So with that, as I'd mentioned earlier, a recording of the webinar will be made available via email. I want to thank everybody for attending today's webcast. Vlad, thank you for sharing your expertise, your knowledge, and your time with us today. I hope everyone has a wonderful rest of your day. Thanks again for coming, and take care. Bye-bye.
Thanks, everyone.